guys, in this video we will be coming up with the introduction to the chapter, some applications of trigonometry. Last chapter we came about with the introduction to trigonometry, and in this chapter we will be coming up with the applications of trigonometry, that what we learned in the last videos, we will be applying it in upcoming videos. Now let's get into applications of trigonometry. What is applications of trigonometry? Where can we apply trigonometry? Now, if I am standing straight and looking at the lizard or insect on the wall, now there will be an angle formed here, and from my eyesight to the eye level, we have an imaginary line called horizontal line. Now, if I am looking at there, now the angle formed here is, there is an angle formed with the horizontal line and with the line made by me, my eyesight, and this line is known as line of sight. Now these both lines would have formed an angle here. If I am looking here, there will be an angle formed here. We will be finding it, not only this, something related to this. Now if I am throwing this ball, I am throwing it in a straight way, but it is going here and I am catching it here. Now there will be a angle formed here. So to find that angle, we can use trigonometry. Now we can get into some examples. Now let's take some example. A man looking at a kite, and this will be the line of sight as he is looking at, and a line from our eyes will be straight. So this is known as horizontal line. Now they can ask, like, they can give the measurement of horizontal line and line of sight, and they can ask the height of the kite, and or else they can give an angle and find either of the things. Now here the angle is above the horizontal line. We can take another example, like a person is looking below in watching a coin that have fell down, and the horizontal line will be straight to his eye. So this will be the horizontal line, and this is line of sight. Now here the angle is above horizontal line, whereas here it is below. So there are differences. Now the difference is, this angle is known as angle of elevation, and this is known as angle of depression. Now it is angle of elevation because it is above the horizontal line, and this is below the horizontal line. So there are two kinds of angles in this case. Next we can get into some example sums. We can take example 1 in page number 198. Here a tower stands vertically on the ground. Let us take a tower, something that is similar to a tower. Let us consider this as a tower now. Next, it is given that from a point which is 15 meters away. It is not given that it is left side or right side. So we can take any side that is 15 meters away. So let's take it this side. 15 meters away from the foot of the tower. Yeah, foot of the tower. And angle of elevation of the top of the tower is found to be 60 degrees. Now it is given as top of the tower, so you may think that this angle is 60 degree, but not. Here it is 60 degree. It is from the top, so we have to take it like this. Okay. Now we can take this as 60 degree. Now it is said to find the height of the tower. Now it is given as 60 degree. We have the side adjacent to the angle, and we have to find the side opposite to the angle. So opposite and adjacent in the formula is tan or cot. Usually we use sine, cos and tan. So we take tan now, and the angle is 60 degree. So we take tan 60 is equal to opposite, that is height of the tower. Height of the tower divided by adjacent side, that is 50 meter. Now tan 60 we know it as root 3. So root 3 is equal to, we can take height of the tower to be h. So h divided by 15. Bringing it here, we get 15 root 3 to be the height of the tower. So these are some examples of applications of trigonometry. There are plenty like this. We can go with it day by day. For that, if you want to follow my videos, do subscribe my channel and like and share my videos. Next, we can go with some exercise sums. That is from exercise 9.1 from page number 203. Here, it is given that a circus artist is climbing a 20-meter long rope, which is tightly stretched and tied from the top of vertical pole to the ground. Okay. Now, let us consider this is the vertical knob and this is the ground, and between the rope is tied for a circus artist to climb, and he is climbing here. Now the height of the pole will be like this. Now this is 20 meter. Height of the pole has to be found. Let us consider it as x. Then the angle made is 30 degree by the rope from the ground to the top of the tower. So it's 30 here. Now we have to find the height of the tower, height of the pole, that is x here. Here we have 30 degree, and we have to find the opposite while hypotenuse is given. Now we can take the ratio which has opposite and hypotenuse, that is sine and cosecant. So sine we can take. Now sine, and angle is 30, so sine 30 is equal to opposite is x divided by hypotenuse is 20. Now sine 30 is 1 by 2 as we know. 1 by 2 is equal to x by 20. Now we can cross multiply it. We get 20 is equal to 2x. Now bringing this here, we get 20 by 2 is equal to x. If we cancel, we get 10 is equal to x. The height of the pole is 10 meter. Now next we can find another sum. The second sum in the same exercise. Here it is told that a tree breaks down due to storm, and broken part bends down so that the top of the tree touches the ground, making an angle 30 degree with it. We can take a tree, it has broken down, so it would be in this shape, not much longer. Due to some storm, it came into this state, and it makes, there is here this line we can consider as a ground. It is told that the broken part touches the ground and forms 30 degree with the ground. So we can take this as 30 degree. Now, the distance between the foot of the tree to the point where the top touches is 8 meter. Now, find the height of the tree. Now, finding the height of the tree does not mean only this part. Also this part, because this is also the tree. This tree have broken into in this condition. We can assume it to be in triangle. So we have to find this part in this part. Now first we can find this part and then this part, then add them both. Now we have angle 30 degree. For angle 30 degree, we have the adjacent side. We have to find opposite and hypotenuse. First, we can use opposite. For finding opposite, we can use sine 30. So, sine 30 is equal to opposite by hypotenuse is not given here. So, we cannot take sine 30, while we can take cos 30 as we have adjacent and we can find the hypotenuse. So cos 30 is equal to adjacent by hypotenuse, and cos 30, the value of cos 30 is root 3 by 2 as we know. So root 3 by 2 is equal to, adjacent here is 8 and hypotenuse is same, so hypotenuse. So cross multiplying it, we get hypotenuse root 3 is equal to 8 into 2 is 16 as we know. Now we can bring this here. H is equal to 16 by root 3. We have to rationalize it. So we multiply root 3 by root 3 with 16 by root 3. So we get H is equal to 16 root 3 by 3. Now we got this part. Now we have to find this part. So we can use sine 30 now. So sine 30 is equal to opposite by hypotenuse. Opposite is 16 root 3 by 3. 16 root 3 by 3 by... Sorry, we know that hypotenuse is 16 root 3 by 3 and opposite has to be found. So opposite by 16 root 3 by 3 and sine 30 is 1 by 2 as we know. So we can substitute. Now this 3 can be brought out here. So 1 by 2 is equal to 3 into, this is opposite, not 0, 16 root 3. Now if we cross multiply, we get 16 root 3 is equal to 3 into 2 is 6 into opposite. Now we can bring this here. So 16 root 3 divided by 6 is equal to opposite. Now we can cancel it using second table. So we get 3 and 8. So 8 root 3 by 3 is opposite. Now we can add them. So 16 root 3 plus 8 root 3. Sorry, whole by 3. As we have the denominator common, we can write it like this. Now 16 plus 8 is 24. So 24 root 3 by 3. 3 ones are 3 and here 8. So 8 root 3 is the height of the tree. Let's check with the answer. Yes, we got it correct, and it is 8 root 3 meter. And that's it for today. For more videos, do subscribe my channel, like and share my videos. Bye.